This is the key component in converting to belt drive. This sits up at the very top of the quill, and I guess this part is a quill spindle, I'm not sure, but anyway it is driven or drives the main quill with the splines in here, and this bottom part sits in an oil seal, and there was originally at this point here there was a gear, and I've machined the gear off and just machined that flush at that point. I just didn't like the gear sticking out. It's quite hard steel, but it does turn okay with decent inserts. And then there was a second gear sitting in here which was loose and fitted on a keyway, and then there are two bearings. These are the old bearings that I took out, and they fit in there. And then there's a circlip that fits in there. So at the very top, above the top of the case, this sticks up and is machined so that it can take a pulley which will stick out like so, and there'll be a threaded section at the end here with a castle nut in, and a castle nut washer, which will be the same arrangement that Sam did on his. And then the only other thing, and that piece there, that's where the point at which this particular part terminated, and you can see the shiny bit and the slightly duller colour. This is the bit I've added, and what I did was so that was at there 5.5 millimeters, and I machined this in 24 millimeters for half of the 5.5 millimeters, and took that piece away, machined that bit out, and then I made a second piece to go, this end piece to go in here, that shape, and that is I've made out of EN10, which is quite tough, and you can tell it's tough because the shavings come off blue, but it does machine quite well with the inserts I've got, and I will not have to do anything to it because it's in toughened, hardened condition. It is quite tough steel and should be quite adequate, because there's quite a thickness of wall here despite having machined out, and this steel is pretty tough too, so I don't have any worries about it. This piece was just simply turned and then inserted in here and Loctited in place, and the internal dimension of that is the same as the internal dimension of that. So my next job will be to machine this, and then I've got the bearings mounted already. This will just be a press fit from down below into the block, and then the circlip goes on the top, and then the pulley goes on the top of that. So it's not all that long now before I could be ready to finish that as soon as the locking nut arrives in the post. Right, now I've machined the end of the quill where it's turned to fit a wheel which will be a pulley, and it's threaded at the end. The threaded end is fitted with the washer, and I've got this in the mill ready to cut a keyway in here so that it will take the tongue on the wall. So that screws on to secure the pulley, which will fit between that surface there and that surface there. Right, this is the belt drive fitted onto the mill. I've included now, as well as the tool changer here, I've included a slotted disc so that I've got feedback and be able to monitor the RPM. So it's a bit difficult to photograph any of this, but I can at least give you an idea of how quiet it is when it's running. That's at maximum speed. And that's about 1,200, 1,300 RPM, which is the speed that I'd often be machining at. That's at the spindle end. The motor maximum RPM is, let's have a quick look, 4,800. But it steps down because there's a small pulley on the motor end and a larger pulley at this end, and I'm measuring obviously the RPM on the spindle because that's helpful to know what you're machining at. So I'm well pleased with that. That's proved to be spot on. The only thing is whether I want to increase the power of the motor, and I have got a larger motor to fit. So that's the belt drive completed and running.